Hello friends, welcome to chapter 4. In this first lesson, well really for the whole chapter, we're going to be talking about exponential and logarithmic functions. In this first section, we're just going to introduce all the basics of exponentials and introduce a little bit of logarithms. So we're going to start right here with our exponential rules. Now, I am actually going to change this this A, there we go, to a B. So we're just going to go through very quickly and define all of these things. All of these rules should be reviewed for you guys, but I understand some of them may have been a little while ago, so they may sound pretty new. But just a reminder that if you have anything to the nth power, what you're doing is you're timesing that thing by itself over and over n times. So if I had b to the 4th power, I would do b times b times b times b 4 times. The zero exponent rule, anything to the 0 power equals 1. The first exponent rule, anything to the 1st power is itself. Product rule, if we are multiplying, then you add the exponents. So you've probably seen things like this, x squared times x cubed. We add the exponents to get x to the 5th. Quotient rule, if we're dividing, we subtract. Just like multiplying is addition, dividing is subtraction. So if I have x to the 8th over x cubed, subtract those numbers, gives me x to the 5th. Power rule, if you have something raised to another power, that is where you multiply. So I have x squared raised to the 3rd. Then I would multiply those and get x to the 6th. Negative exponent rule. If you have a negative exponent, think that I can secretly put this over a 1, make it a fraction. You can flip that fraction and the exponent will change signs. And that works if it starts in the denominator. So if you have b to the negative x in the denominator, you can flip it and the exponent changes signs. Fractional exponent rule, this is actually the square root rule. So you can actually change a fractional exponent into a root, where the numerator of your fraction goes inside the root, and the denominator of your fraction goes outside the root. So those are all of our exponential rules. You are expected to have these memorized. Like I said, they should all be reviewed. With that, let's move on and do example 1, and then we'll end this video. This one's a pretty simple example. We have the value of a car that can be modeled by this equation. Let's highlight it. Where, of course, x is greater than 0 because it's the age of the car. Age of a car can't be negative years. And v is the value in thousands of dollars. So we're going to find v of 0 and v of 7. So plug 0 in. Anything to the 0 power, we just said was 1. So 0.8 to the 0 power is 1. 25 times 1 is 25. And we said that v of x is the value in thousands of dollars. So this is actually $25,000, which is the value of the car at 0 years old. So hopefully that will help with that one. I want you to take a second, pause the video, and try v of 7. Plug 7 in. You will probably need a calculator to figure this one out, and then come back and check your work. Let's see how you did. So we plugged in 7. I just typed that into my calculator to get that. Remember, this is in thousands of dollars, so that's $5,242.88, which is the value of the car when it is 7 years old. And it makes sense that the value depreciated, went down, because we know that value of cars go down with age. And then if it gets old enough, it starts to go up again. So that is a brief introduction to exponentials. In the next video, we'll talk about graphing exponential functions.